Hello everyone, good evening. My name is Emmanuel Philibus and with me is my mate, Mr. Umar Sani. Today we're going to present our video on an assignment on a course MCSS 1023 Advanced Data Structure and Algorithm. The project is titled Project 2 and our group has been assigned to actually write a program on Radix sort and Quicksort algorithms. The two algorithms are meant to actually sort three different kinds of data in this project. The student peer, as I mentioned, is Umar Sani and Emmanuel Philibus with our registration numbers as stated. The course lecturer or instructor for this course is Associate Professor Dr. Dayan Norhayati Abang Jawawi. First of all, we will take the highlight on this assignment. On the highlight, we have a brief introduction on Radix sort and Quicksort algorithms. Radix sort is an integer sorting algorithm that sorts data by grouping the keys, taking the digits individually so that they share the same meaning at a meaningful location and value. Radix sort uses cutting as a subroutine to sort a number array. Because integers can be sorted to represent strings by hashing the strings to integers, Radix sorting works on types of data other than integers. Because Radix sort is not based on comparison, for running time, it is not bound by a gamma of n log n. It can actually perform in linear time. Radix sort incorporates the counting sort algorithm. On the other hand, Quicksort is a partition-based sorting algorithm. It is also referred to as sorting partition exchange. The basic concept of the Quicksort is the idea is that it selects one element from an array and rearrange majority of the elements around it. The main list is divided into two sub-lists by this item. This selected element is called the pivot. Once the pivot is chosen, all the elements are shifted less than the pivot to the left of the pivot. Values and all the elements greater than the pivot are transferred to the right side. This method of selecting the pivot and partitioning the list is applied recursively before sublists consisting of just one variable are applied. This is the brief introduction. So we will go into the implementation. In this project, the Radix sort is implemented on three kinds of data array. First, it sorts 100 integers. Next is 500 integers, and the third is 1000 integers. The code is written in such a way that a random generator method generates the unsorted random integers in the size of the three specified groups. The Radix sort is then called on each of the integer values, where the is the size of the inputs 100, 50, and 1000. See the function specified below for more detail. Next, we are going to show you how you run this program in C++. The implementation is actually done in C++, and our application program or the IDE independent development environment used to write this code is code blocks. So to load my code blocks, I will double click this flight arrowed shortcut on the desktop. Good. Our code block has been loaded and is up and running. Next, we will open the project. Click on File, click on Open. Then we will locate our project. This is our project assignment 2. So we will load this project. Okay, the project is loaded. Inside the project folder, we have a file called main.c++. This is the file that contains our code. And the code is here displayed on the screen. Let's take a look at the code itself. These are the header files. These header files contain the various C++ libraries that are imported for use. Note that the line define array here defines the size of the array that the program is going to sort. Next, we have a void method here, Radix method, that does the execution of our program. So from the main method is here that runs the program. We have a line here that generates random numbers. This line generates 1000 random numbers, and using a method called random generator or random. So we are going to run this program. To run this program, we'll click on Build and Run. Our program has executed successfully. Now we will look at the code and then as we inspect. So looking from the top here, you will notice that it has generated the unsorted numbers. It says generated numbers, random numbers before sorting. These are the 1000 numbers generated on the screen. So we have those numbers generated. Below here, there is a separation, a space provided to separate the unsorted generated random numbers from the sorted output. Here on the sorted output, it reads sorted random numbers using Radix sort. So this is the result of the sorting when the Radix sort method is applied. And we have the sorted result displayed. So this is the result of the sorting. And the 1000 integers have been sorted to this end. You can see the last sorted value, the highest value is 1000. Next, we're going to quit this and then demonstrate how you can run the same program when the input size is reduced to 500. So for 500, we have edited the size of the array to 500. And I'm going to save this and then click Build and Run. This time around, notice the size has reduced. This size is now 500. You can notice the size is not as large as the previous one we executed. So similar operation applies. Then next we're going to show how you can run this when the integers are reduced to 100. With a size of 100 integers, which I have edited, I will click Build and Run. Now notice the reduction in the size. The size has greatly reduced to only 100 integers. So the sorted result of the generated 100 sample is here displayed. So that is that on the Radix sort. Next, we are going to demonstrate the Quicksort. So to open the Quicksort project, I'm going to close the Radix sort. Then we'll open the Quicksort project folder. Click on open. Then we will go back to our projects and then navigate to Quicksort. This is the Quicksort. So we will open the project, and as well we'll double click on the main file and then click on run. Now as for the Quicksort, it generates and sorts at the same time, and these are the values generated in the size of 100. So with this, we have come to the end of this demo, and that is all we have on project 2. Thank you, and then see you in our next video.